there everyone, let's do this problem. It says, do the indicated sp³ carbons lie in the same plane as the sp² carbons in the following molecules? So how do we know whether or not they're going to be in the same plane? Well, sp² carbons are always in the same plane. sp³ atoms that are directly connected to these sp² carbons, so sp³ atoms, I'll write it as less than 1 atom away, are also always in the same plane. But sp³ atoms that are 1 or more carbons away, or 1 or more atoms away, are not going to be in the same plane. Okay, so we're basically looking at our compounds and counting how many atoms or how many carbons are in between the sp² carbons and the sp³ carbons that they circled. So starting with structure A, we have 2 sp² carbons, one on either side of the double bond. I'm going to highlight them in blue. So these are not directly connected to the sp³ carbons, right? We have 1 carbon in between these 2 carbons and same on the other side of the compound, right? They're symmetrical. So since they are 1 carbon away, these are not going to be in the same plane. Okay, looking at structure B, again, we have those 2 sp² carbons on either side of the double bond, and there are no carbons, no atoms in between, so they are 0 atoms away, 0 carbons away, so those are going to be in the same plane. And with structure C, those sp² carbons on either side of the double bond are directly connected to those sp³ carbons in the methyl group. So those are also 0 atoms away. So those will also be in the same plane. So to summarize, part A, the indicated atoms and the sp² atoms are not in the same plane. B, the indicated atoms and the sp² atoms are in the same plane. And C, the indicated atoms and the sp² atoms are in the same plane. So that makes B the correct answer for this problem. That's it for this one. I hope this video was helpful, and thanks for watching.